In this video, we will discuss about the case of definite integrals on adjacent intervals. Normally, we always express the integral as the area under the curve from A to B. So in this case, it's the total area of these two. Let's say we have C somewhere in between A and B. Okay, C is somewhere in between A and B. So actually what we see here, we can split the area into two segments. The first segment is from A to C, and the second segment is from C to B. From the area definition, then, for the adjacent integral, okay, so, from integral of A to B of f of x dx will be equal to integral from A to C f of x dx plus C to B f of x dx. It might sound too simple, but very useful. For example, here I give you an illustration of an fx that can be seen as look like two function, but this is, of course, this is continuous. This is a definite integral. So we have from A to C, but you see here that A to B kind of like one function and B to C kind of different function. In this case, or you see here there is a drop suddenly at point B. So we can make it simple to solve this definite integral by segment it, by make it as two sum of the two definite integral. So integral from from A to C, the total area under the fx from A to C will be equal then to integral from A to B f of x dx plus from this is B to C f of x dx. Let's see how we can apply it in solving problem. Here we're given the graph function of f given along with the area of each region. The graph form with the x-axis. Here you see that area under the curve from x equal to minus 7 to 3 equal to the area is 8 from minus 3 to 0. This area is under the x-axis, so this is minus 1, and then from 0 to 4 minus 7, from 4 to 7 it's plus 2. So the question is, what will be the area under the curve of f of x dx from minus 5 to 7 plus the area under the curve of f of x dx from minus 5 to 0. So since we are given here the value, so minus 5 is somewhere here, so it's here, so here that will be the first term. Okay, the first term will be here is plus, the area will be plus 4, and then the second term we have two function. Okay, it's from minus 5 to 0. So the second term I can split it down, so here I can rewrite it as integral from minus 7 to 5 f of x dx plus, okay, integral, so I will split it, I will stop until minus 3, so I will do integral from, so this is minus 5, sorry, minus 5 to minus 3 f of x dx plus integral from minus 3 to 0 f of x dx. Then I can see it from the graph. This term is actually plus 4, this one is plus 4, and this guy is, because of this is under the x-axis, this is minus 1, so I can solve this as follow. So it's 4 plus 4 minus 1 equal to 7. Yeah, we have another exercise, same as before, but in this case we have an integral, the area under the curve of fx dx from minus 4 to 5. So minus 4 to 5, so it's basically from this one to this one. As you can see here, there are two blocks, so I can easily separate the two by splitting this integral. So this is from minus 4 to 0 f of x dx plus from 0 to 5 f of x dx. And you see the first form, because it is under the curve, so this one is actually minus 6 and this guy is actually plus 4. So this is minus 6 plus 4 equal to minus 2. It will be very useful in many cases.